Next video, this is still just going to do more examples with substituting using definite integrals. Okay, so here we go. Let's look at this one right here and see where this takes us. So again, we got to let u equal something. If we're trying to substitute, let u equal something that if we take the derivative of it, we're going to get something similar to what we already have. Alright, so everybody, we've done quite a few practice problems like this. You should be recognizing what we should let u equal in this case. So you've really got two options. Do you want to let u equal x, or do you want to let u equal x squared minus 4? I think the best thing to do is let it be x squared minus 4, because if we take the derivative of that, it'll be something similar to x. Okay, so here we go. Let u equal x squared minus 4. So therefore du is going to equal what, guys? That's right, 2x. dx. Don't forget that. Alright, so let's keep it going. So I'm going to try to replace my u here and see where that takes us. So this is going to be the integral from 0 to 1 still. And before I do that, let me make sure, just like in the last problem, I'm going to write it as x equals 0 to x equals 1. Okay? Because I'm going to start plugging in my u's now. Alright, so here we go. So this is going to be the same thing as, now I know for right now I'm going to have x values and u values in here, but I'll try to make a connection here. So here we go. This is going to be the same thing as x over u dx. Okay, now before I do anything else, I just want to make sure you guys are aware of this. I know the dx are over here off to the side, but couldn't we always, isn't this over 1? So if we wanted to multiply those, you multiply straight across. So this is going to be the integral from x equals 0 to x equals 1 of x dx over u. Okay? Now guys, here's what I want you to focus on. This right here, x times dx, isn't that very similar to this? 2 times x dx? Okay? So if I wanted to, I could write it as 2 times x dx. But what would I have to do to counteract that? I can't just be multiplying numbers here just because that changes the value of it. So what I'd have to do, if I multiply by 2, I have to multiply by 1/2 at the same time. Okay, so now if we look at what we have on top, isn't that du? So I could rewrite this as 1/2 times the integral, as x goes from 0 to 1, of du over u. And just to, hopefully this makes sense, if you wanted to, I could move that du back out, okay? Just properties of fractions, guys. So isn't, for example, isn't x over 2 the same thing as 1/2 x? So if we have du over u, that's the same thing as 1 over u times du. Alright guys, now look at your formula page. If you try to do this the polynomial way, where we just add 1 to the exponent and divide by the new exponent, you're going to get something that's undefined. So we need to rely on our formula page here. Okay? So look at that, and we have a formula for this. The integral of 1 over u du is the same thing as, I can go ahead and evaluate this guy. It's the same thing as ln of the absolute value of u. Okay, so just apply your formula there. Right, that's all there is there. That's all I'm doing. So guys, the integral of 1 over u du is always going to be ln of the absolute value of u. Now normally we would put plus c, but since we're dealing with a definite integral, we don't put a plus c. So there we go. We still want to evaluate this guy from x equals 0 to x equals 1. Okay, let's keep it going. Next thing. Well, I can't plug in x values yet, but what I could do, and this is the way, that's kind of the way I prefer it. Again, you guys might prefer it the other way, but this is ln of, I'm going to replace u. What do we let u equal? Well, it's x squared minus 4. Okay. We want to evaluate it from 0 to 1. So since I know I've got x values here, I can get rid of my x equals. I mean, you could keep them if you wanted to. But yeah, I'm just going to plug in 0 and 1. So let's do that. Here it is. Okay. So, what do we got? This is going to be equal to 1/2 f of of b, which is 1, minus f of a, which is 0. Okay? Because, again, we're just applying the fundamental theorem of calculus part 2. Okay? It always says we can take capital F of a, sorry, I misspoke, capital F of b minus capital F of a. Alright, so this is b, this is a. Alright, your upper limit of integration is b, your lower limit of integration is a. Okay, so let's just plug in a 1. This is going to be 1/2 of f of 1. Let's do that in our head. So it's going to be ln of 1 squared. One second. Oh, okay, yeah, this makes sense. Ln of 1 squared, which is 1, minus 4 is -3. So hopefully you can kind of see why this is the absolute value. We're going to get ln of -3, the absolute value of -3. If we just had ln of -3, I don't know if you guys remember this, but an ln, a logarithm of a negative number, is undefined. We can't do that. So that's why we have absolute value. It's going to be a positive. It's going to end up being a positive 3. All right, and this guy right here, you got to be kidding me. Just froze on me, guys. This happens all the time. Don't worry, I'm used to it. So let's try to finish this out. Minus f of 0, if we plug a 0 in there, we get 0 squared, which is 0, minus 4, which is -4. So it's going to be ln of absolute value of -4. Okay? Let me exit out of this. I'm going to try to memorize what I had there. It's frozen on me. Let me bring this back up. Hopefully I get this right. All right. Don't worry, you're in good hands here. Which one were we on? This one? This isn't good. Yeah, we're working on that one. So the point we were at, if you need to rewind this, go ahead. But the point we were at, we were ln of, sorry, 1/2 of ln of -3 minus ln of -4. Okay? And so this is 1/2, essentially ln of 3 minus ln of 4. And that just becomes a calculator problem. I think when you type it in, if you type that all in at once, just make sure you do your order of operations correctly. I think you get -0.14 as your answer. Okay. That's what I got at least. All right, let's do another one. Sorry about that. Let's move on. Next problem here is this guy right here. We've got the integral from -pi/2 to pi of 2 times the sine x cosine x dx. So this would be a good one for you guys to try. So I would pause this and just have the students work on this in class. So pause it now, and I'm going to go through it here. All right, here it goes. So what I'm going to do, just talk you through it. I'm going to let u, we're using substitution again, always let u equal something that if you take the derivative of it, get something similar to what you have already. So really, technically, you could let u equal sine x or cosine x. I'm going to let it be sine x to make it even easier on myself. Right. So the derivative of sine x is, well, hopefully you guys got cosine x. So there we go. So I'm going to try to set this up so that it looks like u du, or some expression with u in it, and then du. Okay, here we go. So I want the integral from, as x goes from -pi/2 to x equals pi, and then I want to replace so this is going to be 2 times, well, sine x is u, isn't it? So it's going to be 2 times u, and then I'm going to leave it as cosine x dx. Sorry, I forgot that right there. So it's going to be 2 times u cosine x dx. Okay, makes sense? Hopefully it does. Now, we know what cosine x dx is. Maybe I should have just, well, let me do that here. Hopefully this doesn't confuse you. Let me just write it as times du. So, u is sine x, du is cosine x dx. Okay, so I'm just trying to save myself some time here. Okay, so we can evaluate this now. So how do you integrate to u? Well, you add 1 to the exponent, divide by new exponent. So it's going to be 2u squared over, well, the new exponent is 2 over 2. Okay, and we're going to evaluate that from x equals negative pi over 2 to x equals pi. All right, well, we still got x equals there, right? So we got to plug our, whatever u is equal to, plug it back in. Some expression with x in it. So it's going to be u is equal to sine x. So guys, the 2's are going to cancel, and so essentially we're just going to have sine squared x. And we're going to evaluate that as x goes from negative pi, and well, instead of writing that x, I can just write from negative pi over 2. Again, you could keep that if you wanted it. Pi. Okay, so f of b minus f of a. All right, we need to use fundamental theorem of calculus, part 2. So let's do it. So it's going to be f of pi minus f of negative pi over 2. So let's do that here. So this is going to end up being sine squared of pi minus sine squared of negative pi over 2. Okay, we're going to have to use the unit circle again. So if you look at your unit circle, what is the sine of pi right here? What is the sine of that? What is the y value of that point? Hopefully you guys got the y value is 0. So this one's pretty easy. So the sine of pi is 0. 0 squared, I'll go ahead and write it, but just so you have in your notes, it'll be 0 squared minus, well, let's figure out the sine of negative pi over 2 and then square it. So look at the sine of negative pi over 2. And just to review this concept, if positive pi over 2 is 90 degrees this direction, radians, but in terms of degrees, 90 degrees, then negative pi over 2 would be 90 degrees that direction. So negative pi over 2 radians would be right here. So the same position. So what is the y value of that point? Well, since it's a unit circle, the y value is going to be negative 1. So let's plug that in. Go back. So it's going to be negative 1 squared. Because we got to square the sine ratio. Right? That's what this means. So all we've got is, well, 0 minus negative 1 squared is positive 1, but we still have this negative outside there. So it's 0 minus 1, which is negative 1. Okay, so negative 1 is your answer. That's the area under the curve. Okay, see how much time we've got. It's about 13 minutes in. Let's try to do one more, just for good measure. Yeah, maybe not. Changed my mind. This one's already worked out. I'll have to erase it. So this, I'll stop this video right here.